Hi there Year 7, hope you're all well. Welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you work out 623 plus 1012? Can you then work out 565 divided by 5, 14 squared, then 63,216 divided by 12, then negative 4 multiplied by negative 2, and if you finish all those, have a go at my extension question on the right hand side of the board. Please pause the video for a few minutes and in your rough books or on your mini whiteboards or whatever you have to hand, have a go at those questions now and then I'll go through the answers. Okay, hopefully we all paused the video and had a good go at those. Let's go through the answers. The first one, if you've done a column addition, you'll have got 1,625. For the second one, you needed to do a bus stop division. That would give you 113. Now we know 14 squared just means 14 multiplied by 14. Now you might know that off the top of your head, or you might need to do a column multiplication, or you could have done a grid multiplication to give you 196. This one required another bus stop division, that would give you 5,268. And for the last one, we know that when we have a negative number multiplied by a negative number, that gives us a positive answer, so we should get positive 8. For my extension question, if you had a go at it, the answer I was looking for was 5. Well done if you got that right, that was really tricky. Okay, we're going to go through the diagnostic quiz now, so A, B, C and D. Please write down your answers as we go through and then I'll go through the answers all together at the end. At any point, please feel free to pause the video if you need a little bit of extra time to have a think. So question number 1 for me. What is the answer to the calculation below? 2 times 3 squared. Pause the video if you need. Question number 2. Can you calculate the value of 36 subtract 7 times 2? Again, remember your bips. Pause the video if you need and have a go at that one. Question number 3 for you. The diagram here represents 3/4 of the cakes in a shop. How many cakes are there in total in the shop then? If this is 3/4, how many are there in total? Again, pause the video if you need to have a think. Question number 4 for you. What fraction of this shape is shaded? What fraction of this shape is shaded? Again, pause the video if you need. And the final question for you. A half of 40 is equal to 4/8 of what number? A half of 40 is equal to 4/8 of what number? Pause the video if you need and have a think. Rightio, let's go through the answers. So the answer to question 1, you needed to use your BIPs. That stands for brackets, indices, products and sums. In this one, I've got an indice, 3 squared. 3 squared is 3 times 3, which is 9. I then do 2 times 9, which gives me 18. For the next one again, we've got brackets, indices, products and sums. This time we've got a product here, 7 times 2, so I need to do that first. That gives me 14. I've then got 36 subtract 14, which gives me B, 22. For the next question, if this is 3/4, then I know that 1/4 is just 4 cakes, because this is 3/4. If I split it up, each of those blue boxes is a quarter. Therefore, to find out how many in total, or 4/4, I need 4 lots of the blue boxes, which would give me 16 cakes. Question number 4. We can't tell what fraction of this shape is shaded because each of the parts is not the same size. And to work out the fraction of a shape, if you'd gone for a fifth, for example, you'd need all those parts to be the same size. And for the last one, we know that 4/8 is an equivalent fraction to a half, because I can simplify 4/8 by dividing top and bottom by 2. which would give me 2 over 4. And then I can simplify that again to give me a half. So the question is really asking, a half of 40 is equal to a half of what? Well, it's got to be 40, so the correct answer was C. Well done if you got that right. Okay, let's head into today's lesson. Let's start off by recapping our modelling. I've got x plus 2 is equal to 5. Pause the video for 30 seconds and have a think, how would you model it? Well, I know the green rectangle represents x, and for positive 2 I need 2 yellow squares. So x plus 2 is equal to 5 yellow squares. And I've modelled it. X, the green rectangle, plus 2 positives gives me 5 yellow squares. How would I model this then? I've got 2x plus 2 is equal to 5 plus x. Pause the video for a minute and have a little think. Write down your answer in your rough book if you've got an answer. Okay, we're going to need 2 green rectangles this time because we've got 2x. Positive 2, I'm going to need 2 yellow squares for. I've got positive 5 on this side, so 1, 2, 3, 4 and 5, and then positive x means I need another green rectangle. So modelling that equation, it looks like that. How about this then? How am I going to model this one? Pause the video, have a little think in your rough books. Well, for this one, I'm going to need 2 x's, which are my green rectangles, but this time I've got negative 2. Callum, how do I model negative 2? You're right, I need 2 red squares, thank you. Then for positive 5, I need 5 yellow squares. And Kyle, how can I show negative x? You're right, I need a red rectangle for negative x, brilliant. So I've modelled that equation using my algebra tiles. How can I model this equation using my algebra tiles? It looks very similar. Nathan, negative 2x, how do I model that? You're right, I need 2 red rectangles. Negative 2, just like before, we're going to model with 2 red squares. We know that is equal to 5 yellow squares. 1, 2, 3, 4, 5, and on this side of the equation I've just got one lot of negative x, so I just need one red rectangle. Can you take out your dark blue books for me? Write me the title Modelling Equations. The date today is the 13th or the 14th of January, depending on when you're watching this video. Then put your pens down and watch me. I'm going to model these 4 on the left side, and then there's going to be 4 for you to do in your dark blue books. So title Modelling Equations and the date today, then I'll go through these 4 examples and there's 4 for you to do. Right, I'm going to start with x plus 3, which means 1 green rectangle, plus 3 yellows, is equal to positive 7, which means 7 yellows. 1, 2, 3, 4, 5, 6, and 7. And now I've modelled that first equation. For the second equation, this time I need 3 green rectangles. 1, 2, 3. Negative 2, which is 2 red squares. 2 red squares. And that is equal to x, 1 green rectangle. For the next one, I've now got a negative x in there, so I'm going to need 3 red rectangles this time. 1, 2, 3. I've still got negative 2, so I still need 2 red squares. And this time on the other side, I've got 1 green rectangle, which is x, and then negative 5, which is 5 red squares. And now for our hardest example at the bottom. This time I've got positive 2x, so 2 green rectangles, positive 3, so 3 yellow squares, is equal to negative 2x, which is 2 red rectangles, plus 6, which is 6 yellow squares. Hopefully you can all see that. Okay, over to you guys. In your dark blue books, please pause the video for a couple of minutes and write out the equation and the model for each of these examples for me. Pause the video now and complete those. And these are the answers I was looking for. I've got green for x, take away 3 is 3 red squares, is equal to negative 4, which is 4 red squares. I've got 2 green rectangles to show 2x, subtract 1 is a red square, is equal to x, which is a green rectangle. I've got negative x, take away 4, so 4 red squares, is equal to negative 5, which is 5 red squares, plus 2x, so 2 green rectangles. And for the last one, I think I need one more green rectangle in there. So I've got 4x, which is 4 green rectangles, plus 3 is equal to negative 2x, so 2 red rectangles, and negative 3 red squares. Well done if you got those right. Please correct them in your dark blue books if you didn't. Right, we're now going to see how we can solve these equations using the algebra tiles and then write down what we're doing as we go along. When we see the equations to solve, we first need to draw it out. We're going to do this for every question until we're sure we can get it correct without the pictures. If you go wrong, that's absolutely fine, but go back and draw the picture to help you. Okay, so if you feel confident and you're ready to stop drawing the pictures, that's absolutely fine, but the minute you start getting them wrong, go back to the pictures because the pictures are going to help you. So here I've got x take away 3 is equal to 5. And I've modelled that using my algebra tiles. I've got a green rectangle, subtract 3, which is 3 red squares, is equal to positive 5 yellow squares. My first step, because I want to solve it by getting the green rectangle on its own, is to cancel out these 3 red squares. To do that, I need to add 3 yellow squares to this side, and whatever I do to one side of my equation, I need to make sure I do the same to the other. I can show that using notation. I can say, well, I've added 3 to both sides of the equation, and that's going to give me x on its own is equal to 5 plus 3, which is 8, and I've solved it. I know my unknown green rectangle is equal to 8. Here it is written out for you, and here's my diagram. However, I've got red squares and yellow squares on my diagram, and I know I can simplify that by cancelling out 3 zero pairs, and there we go. The picture now matches my notation. My x is equal to 8, my green rectangle is equal to 8 yellow squares. I'm going to go through an example and then there's going to be one for you to do in your dark blue books. I've been asked to solve this equation, x plus 3 is equal to 5. I'm going to start by modelling it. I know that x plus 3 is equal to 5 yellow squares. This looks really similar to my last example. However, something's changed. This time, to get the green rectangle on its own, I need to cancel out these 3 yellow squares. And to do that, I need to add on 3 red squares. Whatever I do to one side, I need to make sure I do exactly the same to the other. Now, by adding on 3 yellow squares, that means I've added on negative 3 or subtracted 3. That means my equation now looks like x is equal to 2. Let's check my picture matches. Well, if I remove my 0 pairs and then remove my 0 pairs on this side, yes, the green rectangle is equal to 2. It works. In your dark blue books, please have a go at modelling this one for me and drawing the picture. Off you go. Okay, let's go through the answer. This time I'm going to model it with 1 green rectangle and 2 red squares is equal to 7 yellow squares. This time, to get the green rectangle on its own, I need to add 2 yellow squares, and whatever I do to one side, I need to do the same to the other. What that means is I've added 2 to both sides of my equation. If I now remove my sets of 0 pairs, I've got x, the green rectangle, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. X is equal to 9. Does that make sense? Yes, it does, because 7 plus 2 equals 9. I'm going to go through one more example and then there'll be one for you to do. This time I've got x plus 3 is equal to 2. So a green rectangle plus 3 yellow squares is equal to 2 yellow squares. Now to solve it, I want just the green rectangle on its own, so I need to add enough red squares to cancel out these 3 yellows. I'll add on 3 red squares, there they are. Whatever I do to one side, I do exactly the same to the other. And by adding on 3 red squares, what I've done is I've subtracted 3 from both sides of my equation. Let's remove the 0 pairs, shall we? There's 3 0 pairs there, let's get rid of those. There's 2 sets of 0 pairs there, so x, my green rectangle, is equal to -1, or 1 red square. Over to you guys, Year 7. Please pause the video for a minute or two, and in your dark blue books, solve this guy. Right, let's go through the answer. This time, if I model it, I need a green rectangle and 3 red squares is equal to 5 red squares. Now to solve it, I want just the green rectangle on its own, and to do that I need to cancel out the 3 red squares by adding on 3 yellow squares. I do the same to the other side. I'm now going to remove my 0 pairs. First of all, I'm going to add in my notation. By adding 3 yellow squares, that means I've added 3 to both sides. If I remove my 0 pairs in my picture, there's 1 0 pair, there's another 0 pair, and there's a third 0 pair on this side. I do the same on the other side. And this time I'm left with x, the green rectangle, is equal to -2. Okay, Year 7, on your mini whiteboards or in your rough books, pause the video for 30 seconds, solve this one. Feel free to use the model. Okay, hopefully you'll have ended up with subtracting 4 from both sides, which will have left you with x is equal to 1. Mini whiteboards or rough books, solve this one. Okay, hopefully we'll have added 4 to both sides, which will leave you with x is equal to 9. How about this one? Pause the video and have a go at it in your rough books. Okay, in the same way we're adding 4 to both sides, and if you'd modelled it, you'll have ended up with x is equal to 3. Mini whiteboards or rough books, solve this one. Okay, this time hopefully we'll have subtracted 4 from both sides, or added on -4, which will leave you with x is equal to -2. Okay, Year 7, in your rough books or on your mini whiteboards or on a rough piece of paper, whatever you have handy, please pause the video for 10 to 15 minutes and have a go at solving these equations for me. If you finished all the questions on the left side, please have a go at my extension questions on the right hand side. They're a little bit trickier. Pause the video and have a go at those now, please. And the answers are up on the board. Please check your work and see how you did. Don't worry if you got some of the extension questions wrong, we'll be moving on to that in the next lesson. And that's the end of today's lesson. Thanks for listening, Year 7. Please head on over to Google Classroom and submit today's exit ticket, which will be a series of questions to allow me to assess what you've learnt today and identify any misconceptions you might have. Thank you very much and have a wonderful day. Off you go. Goodbye.